In 1995, the British Medical Journal published an astonishing report about a 29-year-old builder. He accidentally jumped onto a 15-centimeter nail, which pierced straight through his steel-toed boot. He was in such agonizing pain that even the smallest movement was unbearable. But when the doctors took off his boot, they faced a surprising sight. The nail had never touched his foot at all. For hundreds of years, scientists thought that pain was a direct response to damage. By that logic, the more severe an injury is, the more pain it should cause. But as we've learned more about the science of pain, we've discovered that pain and tissue damage don't always go hand in hand, even when the body's threat signaling mechanisms are fully functioning. We're capable of experiencing severe pain out of proportion to an actual injury, and even pain without any injury, like the builder, or the well-documented cases of male partners of pregnant women experiencing pain during the pregnancy or labor. What's going on here? There are actually two phenomena at play: the experience of pain and a biological process called nociception. Nociception is part of the nervous system's protective response to harmful or potentially harmful stimuli. Sensors in specialized nerve endings detect mechanical, thermal, and chemical threats. If enough sensors are activated, electrical signals shoot up the nerve to the spine and onto the brain. The brain weighs the importance of these signals and produces pain if it decides the body needs protection. Typically, pain helps the body avoid further injury or damage, but there are a whole set of factors besides nociception that can influence the experience of pain and make pain less useful. First, there are biological factors that amplify nociceptive signals to the brain. If nerve fibers are activated repeatedly, the brain may decide they need to be more sensitive to adequately protect the body from threats. More stress sensors can be added to nerve fibers until they become so sensitive that even light touches to the skin spark intense electrical signals. In other cases, nerves adapt to send signals more efficiently, amplifying the message. These forms of amplification are most common in people experiencing chronic pain, which is defined as pain lasting more than 3 months. When the nervous system is nudged into an ongoing state of high alert, pain can outlast physical injury. This creates a vicious cycle in which the longer pain persists, the more difficult it becomes to reverse. Psychological factors clearly play a role in pain too, potentially by influencing nociception and by influencing the brain directly. A person's emotional state, memories, beliefs about pain, and expectations about treatment can all influence how much pain they experience. In one study, children who reported believing that they had no control over pain actually experienced more intense pain than those who believed they had some control. Features of the environment matter too. In one experiment, volunteers with a cold rod placed on the back of their hand reported feeling more pain when they were shown a red light than a blue one, even though the rod was the same temperature each time. Finally, social factors like the availability of family support can affect perception of pain. All of this means that a multi-pronged approach to pain treatment that includes pain specialists, physical therapists, clinical psychologists, nurses, and other healthcare professionals is often most effective. We're only beginning to uncover the mechanisms behind the experience of pain, but there are some promising areas of research. Until recently, we thought the glial cells surrounding neurons were just support structures, but now we know they have a huge role in influencing nociception. Studies have shown that disabling certain brain circuits in the amygdala can eliminate pain in rats, and genetic testing in people with rare disorders that prevent them from feeling pain have pinpointed several other possible targets for drugs, and perhaps eventually gene therapy. Ever wonder how pain relievers work, or how other animals experience pain? Check out these lessons to learn more.